Okay, today we're going to cover fine-tuning language models, a Google Colab workbook or notebook published by Hugging Face, and the URL can be found by the title Fine-Tune Large Models Using PEFT Adapters, Transformers, and Bits and Bytes. So, where are we? We are, oh shit. Google Chrome, where are you? We are we are here where I had to make this notebook copy of fine-tune OPT BNB PEFT IPYNB. So these are notes to myself because there are a lot of weird things with Google Colab, and not everything works as published. This fine-tune, I have to copy it 1, 2, 3, 4, 5, 6, 7, 8 checkpoints in the course of about 45 minutes. And these are the same errors that I keep making, and it's hard to write it down and say, okay, here's what you do. They just publish a collab, and everything's supposed to work in sequence, which of course it doesn't. So let's go through the last copy and figure out what's going on. So the first issue is in Google Colab, it would be nice, the first thing is to save your work. So let's do Google Drive. Google Colab. And we're going to store the models on Google Drive. Here. Whoops. And so what that does is that gives us the ability to not have to download the models anymore, which is a big time saver. So let's mount our own drive. We're not going to add stops to where I stop the video because we're going to go through and see how long it takes. So we should see drive. So this is my Google Drive that I paid, I don't know, $20 a month for or whatever it was. So the next step is to CD, %CD means you move the environment that the notebook session is running in into that drive. So we're going to CD content drive, my drive. So this mounts everything. This changes this working directory, os.cwd, into my drive. So let's just verify that. Okay, that's good. So now, if we save anything, it'll go into this drive. Okay, so let's download the Hugging Face libraries, and we're going to install them. Now, notice that this isn't PyPy. This is actually the GitHub repo for the most up-to-date version, PEFT and Transformers. All these other ones here are from PyPy. Now, this is an issue. Datasets is an issue. If you don't download the most recent version using the $U flag, you'll get errors. And we're going to see that in the next couple cells. Okay, let this load. This is probably the longest cell. Oh, I forgot. I made a mistake. We should be on an A100. Let's do that. We have to redo everything. Okay. The T4 won't run. It'll run out of memory. You get an OOM error. Okay, let's mount the drive. Let's make sure we're there. Let's install our libraries from GitHub. You know, they should use that flag. No border install. Okay, it's going to take a while. Oh, this is wrong. 6.7B. So I tried downloading another model, 350 million, the 350 million parameters. I'm not sure if it works. So let's go through this process first with the 6.7, the 6.7 billion parameter model. And then we can come back and do the 350 million parameter model, see if that runs faster. This is the most trained version. Oh, so there's stuff that's missing. This didn't save correctly. There are issues with missing cells. Okay, so it's still installing. Let's keep waiting. Okay, now it's going to download the models. It should download it to root cache. This is now asking for the HF token, which has already been set in Google Colab. So now you can see that the Hugging Face directory is there. And it should be under snapshots. And there should be a unique identifier. It's 2. So let's do ls3f. Model.safe tensors index at JSON. Okay, let's oh, this has already been downloaded. Is this downloading now? Yes, it's downloading now. So, let's do 3F. Look like there are 2 PyTorch models. So this one is opt-6.7B. So that's one. We'll also need the data sets. Checkpoint shards, or those saved tensor files. That's all this other stuff. PyTorch bin. Torch.model compatibility. Okay. Okay, we're downloaded. Now let's run these cells to download and apply the adapters, which gives us an 8-bit conversion. This is tricky. Okay. weights and biases. Oh, you know what I'm going to do? I'm going to move this. I'm going to move this to another computer. Let me get another computer screen set up. All right. Enter. That's my weights and biases key. So if we don't install this, I find that I can't install this data set. It'll give me this out of index error. That out of index error looks like, what does it look? It looks like this. No, where is it? Here, you get this error message that says, oh, I get this out of it. Let me show you what the out of index error looks like. If how do I just run this cell? So if I don't do this, pip install -u datasets, I get this out of index error, invalid pattern, star can only be an entire path component. And there's nothing on the internet when you do a web search or even in ChatGPT search that tells you that you have to use pip install -u datasets. Okay, that's one issue. The second issue is that if you're not on an A100, you'll get an OOM error. And so that's a separate issue. And the OOM error will look, okay. Before we talk about OOM errors, if you run one of these install scripts like pip install -u datasets, you can get a restart session message, and that restart session message really restarts the runtime. And so you can get, and if you're down here in the cells, what will happen is the tokenizer won't be loaded. And so what that means is the tokenizer was loaded up here in one of the earlier cells, and when you reset it, that means the memory's cleared if you have a restart session message. And so okay, so this makes sense. So that's one type of error. The other type of error is if you download the wrong type of model. So I tried to save memory space by downloading the 350 million parameter model. And you'll get an error like this. You cannot provide purely quantized models. And this was with, so I don't remember if this error message was from that or it was from the memory restart and not loading LoRa adapters. It may have been from, it makes more sense to where the session was restarted and we had to reload the LoRa adapters. Okay, so this is running. This should run to 200 iterations. It's about 50% of the way through. And I think I'm going to end the video here because I don't think I needed to add any more error messages. Let me look real quick if I need to add more notes. I think that was it. I think it runs okay after these 3 issues. Okay, terminating video.